Greetings everyone. We are Team The Teckers from Institute of Engineering and Management, Kolkata, and our problem statement is to develop an ML model-based solution to define captcha. In today's time, almost all the websites on the internet utilize captcha to protect their websites from automated bot attacks and DDoS attacks. However, these captcha interrupt the smooth user experience for the genuine users. Along with that, nowadays advanced bots can easily bypass captchas. Therefore, it is a hinder in the smooth user experience for the genuine users. Therefore, we propose a solution which is a passive detection system that relies on analyzing environmental and behavioral data collected in the background without interrupting the user experience. So we are collecting and analyzing various parameters such as the device information, the browser fingerprint, the network request, the mouse movements, and the typing patterns. Our front end is built with React.js and other supporting JavaScript libraries. What sets our solution apart is its capability to predict and mitigate potential threats like bots or even DDoS attacks in real time using WebSockets. Whenever a user interacts with our website, we are constantly monitoring the mouse and touch interaction, the browser fingerprint, and the keyboard data. All this data is encrypted using the SIH256 algorithm and then sent to the backend server. We utilize a scalable proxy server that monitors network data and any potential threat triggers an immediate response. These data is securely encrypted and anonymized to comply with the UIDI's privacy guidelines. Then, the backend server checks for the data volume sufficiency. If the data collected is insufficient to confirm the identity, then the minimal user interactions are triggered on the front end, such as a simple captcha. The data is sufficient, then that data is decrypted and then sent to the ML model, which then predicts whether the user is a human or bot. If the user is a bot, then it is sent to a new route to verify a captcha. Now, we have developed a machine learning pipeline that uses multiple models working asynchronously. Our model receives our model receives multimodal data which goes for the pre-processing and the extensive feature engineering. All the browser fingerprint, mouse touch and keystroke data along with the network data are sent to the individual models. For behavioral analysis, we employ lightweight anomaly detection technique as we are trying to find a sweet spot between the lightweight model and the fast predictions. The models work together in a co-training setup, combined supervised techniques for known threats and unsupervised learning to detect anomalies and previously unknown patterns. All models feed into an asynchronous decision aggregator which produces a final verdict whether the user is a human or a bot. The aggregated decision undergoes regular retraining through our data and model versioning system to ensure continuous improvement. All the user data is stored in an anonymized way in the database for the ML model batch retraining. Let us now move to the prototype. So this is the solution that we have built for the prototype. Whenever your user tries to fill a form, which is generally there on the UIDI website, our bot detection module gets activated and it constantly monitors the mouse events, the keystrokes, and the click events. Along with that, in the backend, the network data is being constantly sent over to the backend from the proxy server. Let's say a user is filling up the form. So the normal user will fill up the form with a particular speed that is not very fast. These all metrics help the model to detect whether the user is a bot or a human. Once I click on the submit button, I am successfully verified as a user. Let's see what happens when a bot tries to attack our system. We have built a Python script that acts as a bot and attacks our system. It mimics the real human-like mouse interactions. Let's see what happens. So as you can see, the bot has started filling up the form. As soon as it is detected that the user is a bot, the page is navigated to a new route where the bot has to fill up this captcha. These captcha are dynamic, so the bot won't be able to fill up them correctly, and if it fails, the captcha will be reloaded. If it is a user, it will be easily able to verify this captcha. We also have a robust real-time dashboard which shows exactly whether the user is a human or a bot. As soon as any anomalies are detected, it is then projected in the admin panel instantly. As you can see, all the data such as the browser data, IP address, timestamps, and the status whether the user is a bot or a human being is displayed in this admin panel. This way, we are ensuring passive detection of bot with the minimal user interaction.